This presentation is to help you work through and understand what you are doing in the lab and why are you doing it. Okay, so you want to have already read through your instructions, maybe even have started to put them in your notebook. But hopefully this presentation will help you organize your thoughts, organize preparing for this lab, and then helping in the end with your calculations. So here is a general overview of what you're doing in the lab. Okay, so I've broken it down into 3 parts. The first part is when you're forming your precipitate and preparing your saturated solutions. Okay, we're looking to determine the solubility product constant for the precipitate that you're forming. So we need saturated solutions of it. Okay, we want saturated solutions so that we are at equilibrium. You're going to need to let these solutions sit for 30 minutes. So that's why we're starting with this, so it can sit while you are doing part 2, which you are standardizing sodium thiosulfate. Okay, so that's what's going in your burette. You're going to determine the concentration of the sodium thiosulfate so that you can use that in the third part to determine the concentration of your solutions from part 1. Okay, so part 1, you're just prepping your solutions. Part 2 is you're determining the concentration of what's in your burette, the sodium thiosulfate. Then part 3, you're going to be titrating the solutions from part 1 to determine their concentrations. While you're doing part 2, make sure that you're stirring these solutions from part 1 and make sure that there's always solid in there so that we can form a saturated solution. If there's not enough solid in there, then you don't have a saturated solution. One thing that's different than the titration lab is you do not need to refill your burette with each titration. Okay? If you do refill your burette after each titration, you are going to run out of sodium thiosulfate. Okay, there will not be enough for everyone to complete the lab. Once this solution is gone, it is gone. Okay, we cannot prep it again because the concentration will be different. So just be very aware of how much solution you're using. What I would like to do now is go through in depth each of these parts, look at what you're doing, okay, and how you're going to prep it, and then we'll also look at the math and the equations of what's going on at each one of these steps. So part 1, we're looking at forming or preparing our salt and then forming our saturated solutions. So you're going to mix 2 solutions together to get a precipitate of calcium iodate, and it is going to take some agitation, so you're going to want to mix and mix and mix and mix and mix that solution so that you get the most solid that you can out. Once you get your solid, and you're going to filter out the solid. And I will show you kind of how to do that once we're in lab. But we're going to filter out the precipitate and we're going to set it into kind of 3 piles. One pile goes in a beaker with 40 milliliters of DI water. Another pile gets 80 milliliters of, this should be DI water, not KI. And then reserve the third so that in case you make a mistake, you can go back. Also, you can use that third pile to add to either of these beakers if it runs out of solid before you get onto your third step. You want to keep your stir rods separate. Okay, so don't cross-contaminate. If you only have one glass stir rod, you want to make sure that you rinse it and dry it in between going back and forth between these beakers. You don't have to use a stir rod in there. You can just swirl the beaker. That works as well. Just be careful not to spill. All right, so that's what you are doing for part 1. Now let's talk about the chemistry of part 1. So your 2 solutions that you're mixing together, you have potassium iodate and calcium nitrate. and they produce a precipitate of calcium iodate. That's the solid that you're after. Okay, so you're going to filter away your potassium nitrate that's in solution, and you're going to have your solid calcium iodate, and you're going to split this into 3 piles. So here's pile 1, pile 2, save the third pile. In one beaker, you're going to add 40 milliliters of DI water. In the other beaker, you're going to add 80 milliliters of DI water. This, our solid here, even though, yes, it is a precipitate, remember things are slightly soluble even if they are insoluble. Okay, some ions will go into the solution. So what's happening in our solution is we have our calcium iodate that's splitting and going aqueous into calcium ions, and we'll have 2 iodate ions. We want as much of that solid to dissolve as we can so that we are in fact in equilibrium. One thing to ask yourself and to think about is that after your approximately 30 minutes or whenever you finish part 2, okay, will the concentrations of the beakers be different or be the same? And why or why not? So go ahead and think about that. Okay. Think about the fact that we're trying to form saturated solutions and what exactly that means. All right, on to part 2. Okay, what you are doing for part 2 is we want to standardize the sodium thiosulfate. So you're trying to determine the concentration of the sodium thiosulfate that you've been given. Okay. You want at least 2 titrations. You need 2 good titrations, but definitely finish the lab before doing additional titrations. It's worth more points to finish the lab than it is to make sure your 2 titrations are within 1%. In your Erlenmeyer flask, you're going to dispense 10.000 milliliters, so from a volumetric pipette, of your 0.0100 molar potassium iodate. So this has been prepped for you. You're going to also add about 20 milliliters of DI water and about 1 milliliter of solid Ki. Yes, this is milliliter. You are going to measure your potassium iodide. Rather than putting on a balance, you're going to measure it according to its volume. So make sure, probably easiest to use your smallest graduated cylinder, and make sure you don't wash it. Okay, keep it as dry as possible. That's why you want to prep your glassware in advance. All right, then you're going to add 20 drops, which is about 1 milliliter of 2 molar HCl. In your burette, you're going to have approximately 0.025 molar sodium thiosulfate. Okay, so this is what it should be about. You want to do your calculations assuming that it's about 0.03, probably. On the bottle of this, you're going to see that we really do have it as an approximate concentration. It's prepared so that the concentration is actually double this, but because of the complexities of what's going on with this ion, the concentration that you're going to calculate is actually lower than what is anticipated, so you're going to want to anticipate about this molarity. You need to calculate how much of that sodium thiosulfate, again, use this value, that's going to be needed to titrate 10 mils of this solution. You need to know that, and that's because we can't add the indicator until you're close to the end point. So you're going to titrate just shy of your calculated volume, so shy about 5 milliliters. Okay, I would err on the larger side of that, so maybe between 5 and 10 milliliters, not less than. Once you get too close to your endpoint, you're going to add 40 drops, okay, which is about 2 milliliters. Don't bother counting the drops, just administer about 2 milliliters of a starch indicator. And you're going to want to make sure that you shake up that starch every single time before you add it into your Erlenmeyer flask. You're going to add about 2 milliliters. Okay, rinse down the walls of DI water to make sure everything gets down into your Erlenmeyer flask. And your solution is going to turn blue, black, and cloudy in color. You're going to resume titrating, so taking your sodium thiosulfate from the burette, and you're going to go drop by drop, so much slower this time, until this blue-black color goes away. And starch is it's a little bit more challenging of an indicator to use. It's not like phenolphthalein that goes from a clear colorless to a clear pink color. Okay, you're going to have to make a judgment call of when you feel this blue-black has gone away. Most of the time, it's going to go cloudy white. For some of you, it might go cloudy yellow. So you'll just kind of have to observe as you go. And remember, if you think you're close, write down a burette reading and then add another drop and see what happens. It's easier to cross out a burette reading than it is to start the titration over. So that's physically what you are doing for part 2. Now let's talk about the chemistry of what's happening for part 2. So in the Erlenmeyer flask, you've added potassium iodate, potassium iodide, some water, and some acid. In terms of the ions, in terms of the chemistry that's happening, it's the iodate ion from potassium iodate that's interacting with the iodide ion from potassium iodide. The acid is here to provide a balanced redox equation. Good vocab, good application from what we've been learning in chapter 18. Okay. That's from balancing this redox equation. These are combining to form iodide. So this is all happening in your Erlenmeyer flask before you have even started titrating. Okay, and the goal is that we've produced this iodine in solution. In the burette, because we have sodium here, this is completely soluble, so it's splitting apart into the sodium ions and the thiosulfate ion. So this is what's in your Erlenmeyer flask. This is what we're interested in the burette. That's what's being titrated. Okay, when these two react, they form I-, the iodide ion, and S4O6 2-. What's happening for this titration is that the starch, when I2 is present, is that blue-black color. It's really blue, but it's going to be so dark that it looks black. Okay, then the solution should turn colorless. It doesn't usually. Okay. White is ideal, but usually we've been seeing kind of a yellowish tint to the solution. But once this blueness goes away, that means that this is gone. So we have come to the end point of our titration. For your calculation, okay, we're trying to calculate the molarity of the sodium thiosulfate. So you know the milliliters and the molarity of your iodate solution. And you know your volume of sodium thiosulfate that was used, and that comes from your burette. So we take the milliliters of your IO3 minus, the iodate ion, convert it to moles using the molarity. Using stoichiometry, go from moles of IO3 minus to moles of I2, then from moles of I2 to moles of S2O3 minus. So we're using this balanced equation here and this balanced equation here. Then go from moles of S2O3 minus to moles of your sodium thiosulfate. That uses this equation here. You take your moles of sodium thiosulfate divided by your volume from your burette readings to get your molarity of sodium thiosulfate. All right, so that was part 2. Part 3 now is another set of titrations, but you're titrating your 2 solutions from part 1. So you're going to titrate this solution here and titrate this solution here. And remember, while you're going through and doing part 2, you want to make sure that you always have solid present in each of these beakers so that you can prepare a saturated solution. As long as solid is present in these beakers, then you can assume that this is a saturated solution. Both of these are going to be saturated, which means ideally they should be the same concentration. All right, so part 3. You are going to be doing 3 titrations. Okay? You're going to titrate each of your filtrates, so each of your what's going on in your beakers, the 40 milliliter beaker and the 80 milliliter beaker. But remember, we can only add that starch indicator right before we get to the end point, and you don't necessarily know what that end point's going to be. So your first titration is going to be an approximate titration. Okay, essentially you are going to do the worst, quickest titration so that you can get an idea of how much sodium thiosulfate you need to add. Okay. So 3 total titrations. The first one is going to be, you're just going to blow it. Okay. Then your second and your third are going to be good titrations. So you want to take your time on them and add your starch when you should. So you're going to filter out your saturated solutions, except this time you're not interested in the solid. You are interested in the liquid. Okay, that we call that the filtrate. Okay. So when you're separating, keep the filtrate, and that's the liquid. And you want to keep them also separately. In your Erlenmeyer flask, similar components to part 2. Okay, you're going to have 10.000 milliliters of the filtrate. Okay, the filtrate in this case is giving you your IO3 minus ions. Okay, that's what the filtrate is providing. You're going to add your water, your solid Ki, and your about 1 milliliter of 2 molar HCl. Okay, remember this is the iodate. Okay, the water is just there for balancing and to keep things all moving and grooving. This is all about the iodide ion, and this is about the acid being added. Your burette still has your sodium thiosulfate, and you now know the concentration of the sodium thiosulfate because that was what we did in part 2. You're going to titrate your 3 titrations. For your approximate titration, you're going to add your starch indicator right away. So add it right away, blow your titration, see how much of your sodium thiosulfate it takes. Then for your good titrations, okay, you're going to wait to add your starch until you're close to the end point. So you're going to take about a milliliter off from your approximate titration for your bad one. Okay. I would maybe take 1 or even 2 milliliters off from your approximate titration to make sure that you don't go too far before you get that starch indicator in. Remember to shake your starch indicator before you put it in, and then titrate until that blue-black color goes away. I believe in your directions it may say to start out with your 40 milliliter solution. Okay, if you are really good and efficient at using solutions, you can take that 40 milliliter solution. If you are not as good with your efficiency, you may want to start with doing your extra titration with your 80 milliliter solution just because you have more volume to work with. But be aware that you don't want to shy this. You want to go on the larger side versus using less than that. All right, so that's what you're doing for part 3. Now let's talk about the chemistry. It's essentially the same exact chemistry as from part 2. And we still have the iodate ion. It's just coming from a different source. It's coming from your saturated solution. Okay, so we have iodate ion, iodide ion. Okay, we just have acidity there for balancing, making sure the reaction goes. And we're forming the iodine. And this is in the Erlenmeyer flask. Burette still has the same solution. We're after this thiosulfate ion, and it's the iodine and the thiosulfate that's interacting to form iodide ion. What has changed in part 3 is now we do not know the concentration of the iodate ion, and that's what we are after. So we know our volume from our burette. That's what we start our calculation with. We use the molarity that you calculated from part 2 to go from milliliters to moles. And then we use that same kind of stoichiometry path, moles of sodium thiosulfate to moles of thiosulfate, using this equation here. Moles of thiosulfate to moles of iodine, using this equation here. Then moles of iodine to moles of iodate, using this equation here. Then to get molarity, we take our moles of iodate divided by the milliliters of iodate, okay, in liters, of course, to get your molarity of your iodate. Those are the calculations for part 3. Our purpose of this lab is to determine the solubility product constant of our slightly soluble salt of calcium iodate. So next page are the final calculations. So once you've done the lab, you have all of your data, all of your concentrations. Now comes the part of where we actually determine the solubility product constant of the calcium iodate. So here's our equilibrium. Remember when we set up an ICE table with a salt, slightly soluble salt equilibrium, instead of having a plus X and minus X, we use S. Okay, remember the lowercase s, and this 2 comes from our stoichiometry. And you want to make sure that you keep in mind that the concentration of the iodate ion is equal to 1/2 the concentration of the calcium ion. Okay, so keep that in mind. You want to write a KSP expression, and that's our products of our reactants, including the aqueous and the gas phase, no solids and liquids. You want to plug in your experimental concentrations, so we have the concentration of this. Okay, that's what you did for part 3. Keep this reaction or this relationship in mind for plugging in your experimental concentrations and calculate a KSP value. Then compare this to your published value. Okay, Google it, see what the internet says, or use whatever search engine your heart desires. Then we'll also do calculations. S is the molar solubility, so you'll want to also calculate just the solubility of calcium iodate. Maybe check your notes if you can't remember the difference between those two. And then also compare this solubility to published values. Again, look them up on the internet. So that's it. No, it was a lot to get through. Hopefully this will help you just give you a little bit more purpose of what you're doing in lab, and hopefully this will help you organize your lab notebook, the tables of what you need if you like tables, and figure out just what information you need to collect so that you can be as efficient as possible while completing this lab. Another thing to keep in mind is that the beakers, your glassware, is going to be very tight, okay, meaning that you are going to use pretty much every piece of glassware in your drawer. So you're going to want to work cooperatively with your partner on using the glassware efficiently. Make sure you label all of your glassware so you know what it is, okay, and what solution is in there. And just make sure, if you run out of glassware, you're going to have to figure out what glassware you can clean up, what waste you can dispose of, so that you can get some glassware to work with. I wish you all the best of luck. If you have any questions, don't hesitate to ask me. Okay? Make sure you're asking questions when you need to. Best of luck, and see you guys in the lab.